Hey guys, welcome back. Okay, this will be part 2 of the triangle lesson. The first part was just reviewing types of triangles, identifying by their sides and angles, and then we also proved that there's 180 degrees on a triangle, visual way and by a T-chart way. Okay, because that's what we've been doing our proofs up to this point. Today's objective is to talk about the exterior angle theorem. And then at the end of the video, I'm going to prove it using a T-chart. And I'm also going to show you visually why this works too. Hopefully the visual part works. It's hard to do it when I have a whiteboard. I have stuff taped to a whiteboard that you'll see later on. So let's go ahead and talk about it. So the exterior angle theorem, okay, it states that the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles, the two remote interior angles. Okay, so what does that really mean? Well, I think the picture says it a lot better. This angle right here, angle 1, is equal to the measurement of A plus the measurement of angle B, and that's what this statement below is stating for you. Okay, so like I said, end of the video, we'll prove it. But for right now, just take my word for it, it works. This outside angle, the measurement, is these two guys added up. Okay, so honestly, this is a cool, useful theorem because it's something that you can use in future things instead of, finding a measurement of an angle using other methods. This one could be a little bit quicker if you know what this theorem is. So let's try an example out. Okay. So here we go. We're going to find the measurement of JKL. Okay. Now I know this outside, okay, is equal to the remote interior angles in the back here. These guys added up. That's what the theorem states. So that's what I'm going to write down. The measurement of JKL is equal to the measurement of angle L plus the measurement of angle M. Okay, those two guys. So this is using the exterior angle theorem. I am abbreviating, so don't mind me there. All right. And actually, I'll tell you what, I don't know if you can see, because I didn't test this out ahead of time. So let me just enlarge that a little bit. Now, the measurement of JKL, I'm going to substitute. It's 2x minus the 15. The measurement of L is x. The measurement of M is 50. Okay? Now, realistically, once again, I know if you think about outside of a math classroom, for instance, are you going to have algebra like this? No, you're going to come up with measurements is what you're going to have. Okay, and I get that. This is just, once again, just working with your algebra, practicing with it. Get the x's to one side. I like them to be positive, so I'll take the 1x over to here. Okay, and the last step, add 15 to get x by itself. And x becomes 65. Okay? Now, we're not done yet. The question prompts us to find the measurement of this guy. Okay? That's what I want. So, how am I going to figure that out? Well, there's two ways of doing it. You can either substitute 65 into this guy right here, JKL. So, let's see. The measurement of JKL is 2x minus 15. So that's 2 times 65 minus 15. 2 times 65 is 130 minus 15 is 115. So that's the measurement. Can't talk. Okay? So you could use direct substitution. The other way you could check your answer, let's plug it back in for this guy. Okay, so that's going to be what, 65 degrees? And then these two added should give me the outside. So we already know it's 115. Let's check. 60 plus 50, or 65 plus 50 is 115. So yeah, 115. These added to 115. The theorem works. It's not a phony. Okay, we're good with it. So there's our first problem. Okay. Now, could you figure this out Differently, yeah. Given a different set of circumstances, you could figure this angle out first, right? There's 180 in a triangle, so you could find this guy. And then these two are linear, so you can subtract it from 180, and that will give you the outside angle, okay? So it is possible to find it without using the exterior angle theorem, but this theorem is just a really good convenience. Okay, let's go ahead and look at this guy. Same procedure, okay? We're going to find the measurement of angle FLW, so it's this guy out here. Now, unfortunately, we don't know what it could be because there's an x there, so we're going to solve for x first. So what we're going to do using the exterior angle theorem, I know the measurement of that outside angle equals these back angles, the remote interior angles. So the measurement of O plus the measurement of W. So that's the exterior angle theorem. Okay. Now what we're going to do is substitute. So this guy is 2x minus 48. The measurement of O is x. The measurement of W is 32. Pause the video, or hey, tell me, am I going too fast? Hopefully I'm not. I'm trying, like I said, the goal of these videos is to be very concise with everything. So that way it's not like a long drawn out process. Combine the x's, so those cancel. X minus 48 equals 32. Add 48 to both sides. X is going to equal 8. Now, once again, are we finished? No, we're not finished. I have to figure out what this guy is, right? And there's two ways of doing that. I can either plug 80 into here, and these two added should give me the outside angle. That's what the theorem states. So let's do that just to have a reference. If this is 80 now, 80 plus 32, 112 degrees. Okay, so this outside angle should be 112 degrees. Okay, let's test it out. So the measurement of FLW is 2x minus 48. So 2 times 80 minus 48. I think this is going to work. 2 times 80 is 160, minus 48 is 112 degrees. So we're good. Two ways to check your work. Either add up the remote interiors, or plug it back into this guy and see if it equals to the remote interior angles added up. Okay. All right. So I'm only going to do 2 examples because there's really not much to work with here. But what I am going to do to finish this, we're going to prove that this theorem actually works. Okay. So here it is, okay, the exterior angle theorem. So feel free to, if you want to write this down in your notes, okay. I'm going to use a T-chart format. There's other ways of proving things besides the T-chart, but for high school geometry, that's the most popular way to prove things. Left side, your statements. The right side is your reasons. Okay. So right now, we have given to us, and tell you what, just give me one moment. I just want to get rid of the PowerPoint. We don't need that anymore. And then what I'm going to do is move this up closer. There we go. So that way you can see a little bit better. Okay, I think that works. So I'm trying to prove that angle A and angle B added together gives me angle 1. Okay, that's the exterior angle theorem that we're trying to prove works. So we're given that we have a triangle. Wow, that's a lot. That's a lot of information, isn't it? But we're still going to write it down. So triangle ABC is my first step, and that's given to us. Okay? Just the start of the logic here. So here's what I'm going to do. Okay? I want to come up with an equation, and then once again, I'm going to substitute what I want and get rid of what I don't want. So if you remember the triangle lesson, which is the previous video, we did that. To prove it's 180 degrees in a triangle. We do the same thing here. So if I have an equation I'm trying to prove, I need to start with some equation here. Okay? So let's do that then. So if you take a look, 1 and 2, they're linear angles. And we know linear angles add up to 180. So I'm going to go ahead and I'm going to say that angle 1 and angle 2 are supplementary. Okay? And that's just the definition of linear angles. Okay? We know that linear angles are supplementary. So because I established this, now I can go ahead and write the equation out. So the measurement of 1 plus the measurement of 2 equals 180. And that's just because we followed what supplementary meant. So the definition of supplementary, which I'll abbreviate as SUPP. Okay? All right. Now, obviously, I have angle 1 in here. I got 2 and 180. Well, I want B and A. So I'm not anywhere near what I'm looking for. So here's what I'm thinking. Let's come up with another equation that adds it to 180 degrees. So if you look at the problem, we have a triangle, and we know a triangle adds up to 180 degrees, and it includes angles A, B. So that's something I want, right? I want A and B. So that sounds like a good idea. So for step 4, I'm going to say the measurement of A plus the measurement of B plus the measurement of angle 2 equals 180 degrees, okay? And that's just due to the what? Triangle, angle, sum theorem. Okay? We just proved that in the previous video. So the reason why we're adding it to 180 is because there's 180 degrees in a triangle. Okay. Now, you see how this equation and this equation are both equal to 180. So that's telling me that the parts have to be equal as well. These 3 items add up to 180. These 2 items add up to 180. So what I could do is I could substitute technically. I could take this I can't talk. I could take like this 180 degrees out, and I could put this guy in its place. Okay, and that's what I'm going to do. So this statement, I'm going to substitute for the 180. Okay, since they're both equal to 180. So the measurement of A plus the measurement of B plus the measurement of angle 2 equals the measurement of 1 plus the measurement of 2. So that's by substitution. I'll abbreviate SUB. Now, we're almost done. We have an algebra step to go. Okay, you see how we have angle 2 in here twice. All right, and I'll tell you what, let me zoom in a little further. So you can see it a little better. Because I had to write a little bit small here. So we have an angle 2 here and over here. Okay, if I were to combine like terms, I would, if they're adding angle 2, I would subtract angle 2 to get it to the other side. When I do that, these angle 2's cancel. So those are gone. So what I have left is the measurement of A plus the measurement of B equals the measurement of angle 1. Hey, how about that? Look. Isn't that what we just proved? Or isn't that what we want to prove? And we got there by subtraction. Okay, I'll put this in parentheses. We subtracted the measurement of angle 2. That's how we got there. Proof's done. Ta-da! So the outside angle does actually add up to the remote interior angles. Okay? So honestly, and overall, not a bad proof to show that. Okay? Algebraically, it's a pretty straightforward task. Okay? All right. Now, let me show you visually another way. Okay? And I'm hoping that this works out. So here's another whiteboard. Boom. And I'm going to try and zoom in as close as I can so you guys can see this. Okay. So this is angle B, this is angle A, and that's angle C. Okay. So right here, I'm going to extend this out. Oops, that's not a very straight line. Okay. So what we're saying is that this angle outside of the triangle is A and C added up, okay? And once again, we're talking about the exterior angle theorem, okay? So what I'm going to do, and hopefully the tape works with this, I'm literally going to cut off these angles. So here's angle C. It's coming off. I'll just put it over here. Okay, something like this. Right there on the outside. And see how it kind of fills in some of that gap for that angle? Okay. See if I can zoom in a little bit more so you can see it a little better. All right. And then what I'm going to do is I'm going to take angle A. I'm going to take it off the triangle. Oops. All the tape's coming off. And I'm going to put it right there to fill the rest of the gap for that angle. Okay? There we go. See if I could, the tape. This is what I was worried about. Can I do it? I think I can. That's the best I got, guys. Okay? So what that does is, what it's showing you visually, okay, is that these two, and I probably should have reversed the orientation. Let me see if I can make this a little bit better. I think that's, considering the tools that I got to show you, I think this is the best I got for you, okay? But you can see that that fills the gap, okay? Now, can you just do it by inspection to say that it works? You could. I will say the proof, the algebraic proof that we just did before this, I think that shows it, that it works for all situations. But visually, if I take off these two angles, I could fill in that space that's outside, okay? So these two angles added up gives me this outside angle, the exterior angle of the triangle there, okay? Alrighty, so that is it. All right, that's our final lesson when it comes to just the intro to triangles. Next lesson we'll talk about congruency of triangles. All right, so hope you guys are doing well. Have a great day, and I'll see you guys in the next lesson.